So this first question is asking, you're walking through Cherry Creek State Park and you come across a rock. You test the rock and you find that it contains 12.5% uranium-238. Uranium-238 has a half-life of 4.5 billion years old. So two pieces of information that are important within that problem. First, the amount of uranium that's left, which is 12.5%. And then second, how long that half-life is, which is 4.5 billion years. So this is asking how many half-lives would have occurred. So I like to set up a data table when we do these kinds of problems. So my data table, I'm going to have 3 columns. This first column is going to be the number of half-lives. The second column is going to be the amount of that uranium that's left, and that's going to be in a percent. And then the third column is going to be the age of the rock, or how many years have passed. So if we have a rock that has undergone 0 half-lives, that means that it would contain 100% of that uranium-238 when that rock is first made, and the rock would be 0 years old. The 0 years would have passed since the rock was first formed. If we undergo 1 half-life, now half of that original amount is going to decay away into a stable version of the atoms. So we would have 50% uranium-238 left in that rock, and 1 half-life would have gone by, so 4.5 billion years would have gone by. We still need to get to 12.5% though, so we're going to continue this process. If we undergo 2 half-lives, half of 50%, there's now 25% uranium-238 left in that rock. And this rock is going to be, we would add another 4.5 billion years. So we would see that 9 billion years would have had to go by. We still haven't gotten to 12.5% though, so we're going to keep going. At 3 half-lives, we would now have half of 25%, so 12.5% of that uranium-238 would be remaining in that rock. We would add another 4.5 billion years, so 9 plus 4.5 billion years would be 13.5 billion years. So for the question saying how many half-lives would have occurred, 3 half-lives would occur to get to 12.5% uranium. For part B, it says, how old would the rock be? Well, we can see with our data table, the rock would be 13.5 billion years old. And then it says, is your rock from Earth? If we found this rock and it was 13.5 billion years old, this rock would have to be from someplace outside of Earth, because our Earth is only 4.5 billion years old, and this would have been older than that. Okay, so if we continue, we've got one more question. This next question is saying, if you have 100 grams of a radioactive isotope or substance with a half-life of 10 years, how much of the isotope will you have left after 10 years? So we're going to make a data table just like we did before. So this is going to be the number of half-lives. This is going to be the amount. And in this case, it's going to be in grams, because we're now talking about 100 grams of a radioactive substance. And then this is going to be the age, or the number of years that have gone by. So we always start with 0. At 0 half-lives, we are starting with 100 grams of the substance. And 0 time would have gone by, because that's our starting amount. After 1 half-life, we would get 50% of that original amount. So half of 100 grams would be 50 grams. And you would have undergone the amount of time to do a half-life, which in this case is going to be 10 years. We want to continue. So at this point, it says, how much of the isotope will you have left after 10 years? Well, we would have 50 grams left after 10 years. So that's the answer for part A. For part B, it says, how much of the isotope will you have left after 20 years? Well, let's continue this table until we get to 20 years. So at 2 half-lives, half of 50 grams would be 25 grams. And we would be adding another 10 years, so we would get to 20 years. So now after 20 years, we would have 25 grams of this radioactive substance. For part C, it says how many half-lives will occur in 40 years. We got to continue this data table. At 3 half-lives, half of 25 is going to be 12.5 grams. We would add another 10 years, so this would be 30 years. Still haven't gotten to 40 years, so let's continue one more. At 4 half-lives, we would get half of 12.5%. So we would have 6.25 grams of the substance. Add another 10 years, so this would get to our 40 years. So for part C, how many half-lives will occur in 40 years? There would be 4 half-lives. And we would be left with 6.25 grams